My name is Zhanna Lopuliak, and today I'm going to present a paper called On an Approach for Clustering Social Media Data. One of the biggest problems facing researchers today is to gain valuable insights from a tremendous amount of text data. Analyzing a variety of social media text like logs, discussions, amounts of reaction, comments is one of the actively studied fields. Businesses are interested in such data to build personalized models for their customers. The usage of personalized models increases the success of marketing campaigns. We chose this topic because we believe that influence of social networks is rapidly growing last years and will continue to do so. That's why it's important to combine text mining and social network analytics to create more powerful tools so companies can monitor the user's reaction in social media and create a better product for their customers. In our work, we propose a model for users' clusterization based on their social media activity with an accent on their emotional behavior and leadership features using the Cummins clustering technique. On this slide, you can see some related research. The first paper is a review that performs a comparative analysis of approaches of clustering algorithm to analyze Twitter data streams. A review of the literature identified certain studies that implemented different clustering methods. The experimental results, described in the second paper, shows that the Cummins clustering algorithm performs better as compared to a hierarchical algorithm and takes less time for execution for a similar purpose as ours. Based on those two papers, we decided to use Cummins clustering for solving our problem. The third paper focuses on the same idea as we do, clustering customer database for a chosen company. The main difference is that they created a model with an accent on influencer following relationships, whereas the key point of our research is to put an accent on user emotional behavior. The last one summarizes the importance of customer personalization in online marketing. To collect data needed for our purpose, we created a special developer account that gives access to data from selected social media. After getting special tokens and consumer keys, we collected posts and users' data. We were interested in tweets in which users mention the official airline account or their support account, because that's what someone usually would post on their page when he wants to gain the company's attention. For example, give feedback or point out some problems. Following attributes were selected: text of a post itself, number of user followers, number of favorite, number of reposts, and number of lists to which user was added. In the picture, you can see how the raw post object looks like. To make our data suitable for Cummins clustering, we made the following steps. Twitter data is always noisy, so in addition to standard cleaning steps, we also deleted tweets where more than 4 other accounts were mentioned or more than 4 hashtags were put. We also didn't take into account posts from users with more than 1,000 followers, because in a real-world business model, they should be treated individually because of the huge impact they make on the company reputation. To work with numeric instead of textual data, a special analyzer called Vader lexicon was used to measure text emotions. This dictionary is applicable only to English and was manually compiled by a group of people who assess the emotional coloring of words. It is considered the gold standard for the emotional evaluation of short microblogging texts. For a more accurate assessment, even the format of the text, the number of exclamation marks, etc., are taken into account. The figure on this slide shows examples that demonstrate this. A compound rating was used in our work as it gives the most accurate idea of the overall emotions of the tweet. Then, we applied principal component analysis to reduce model dimension and normalized feature range as typical pre-processing steps for Cummins clustering. Let's go into detail to see how PCA worked on our data. We decided to go with 3 principal components that together account for over 90% of the variance. In the left picture, you can see data points before applying PCA. Dimensions are polarity, number of subscribers, and total number of retweets and favorites. In the right picture, you can see the same data points, but now each dimension is one principal component. The dot size corresponds to the number of user subscribers, and the color represents polarity. As can be seen from the figures, the relative position of the points has changed, the data looks more structured, and we can visually identify some groups. Then, to answer the question of how many clusters needs to be built, we first try the elbow method, the result of which can be seen on the slide. We see that the elbow occurs at 4 or 5. The inability to accurately determine the number of clusters is a typical disadvantage of this method. To avoid subjectivity, we will use a more accurate silhouette coefficient to determine the number of clusters. As we can see, the optimal number of clusters for our dataset is 4. After applying k-means clustering on the prepared dataset, we got 4 clusters, which are shown on the pictures here. In the real business model, a company would have a different approach towards them. For example, users who got into the orange cluster are most loyal to the company. These are people company would like to call for help to spread the news and explain new products to other users as they have more followers. At the same time, users from purple cluster who posted negatively are the users the company wants to take care of in order to shift their opinion to a better one. How the company would deal with other clusters depends on its purposes and available resources. In summary, we use the attitude level, the follower number, and a few other features to cluster the community. After normalizing the data, we ran a k-means algorithm and built a few clusters across the community users. The cluster set with 4 clusters turned out to be the best suitable for our data. Talking about future work, we should mention that even by using data just from Twitter, the analysis could be significantly expanded. For example, if a company has a sales issue in a particular area, tweet geodata could be used to determine the main reasons for that. The same idea applies, for example, if the company did an update or launch of a new product on a specific day, so we can measure the reaction for an exact time. The model could also be improved by adding more factual data sources. Since the cluster organization that we have built does not represent all possible users, for example, it does not cover the future users, we could expand our work by implementing immediate streaming classification with already known clusters. A variety of methods could be used for this purpose, for example, logistic regression, random forest, or modern bagging and boosting. Future work on this topic could also focus on clearly identifying the specific causes of customer satisfaction and dissatisfaction. We can get this insight by creating word cloud images, calculating the highest frequency words, etc. At the same time, we can try to improve the existing dictionary used to measure the emotions of the writer by adding new words or by taking emojis into account. One more topic this research can focus on is building and comparing models for other languages but English. This involves using and improving existing tools for sentiment analysis or creating our own tools.